Okay, team challenge number 3 is one of the how to make a buffer questions. Really important that you get this concept from an educational point of view, because we do a lot of buffers in biochemistry and you have to understand the concepts behind buffering. From a practical point of view, from your side of things, because this is going to be on the first midterm and it's going to be on the final exam, so I'm going to make sure that you know it. Okay, so the deal here is how many grams of the salt of the conjugate base, which is given here, and how many mils of the stock solution of weak acid are you going to have to mix to make a buffer. We want to make 700 mils of buffer. We want to make it at 70 millimolar. We want it at pH 7, get the theme of the question here. And the Ka is 7 times 10 to the minus 7, okay? And the heroic acid, the conjugate base is at 70.0 grams per mole. And the stock solution of weak acid is at 0.7 molar. Okay. So the first thing we have to do is a Henderson-Hasselbalch to figure out what our ratios and our concentrations are. We'll do that by putting in the pH of 7 is equal to the pKa. Oh, we got to figure that out. We take the negative log of this number. Negative log of that number is 6.15. Okay, so we've got 6.15 plus the log of A minus over HA. Okay, so we have 0.85 equal to that, which if we take 10 to both sides, 10 raised to the power of this, 10 raised to the power of that, we end up with a ratio of 7.079 is equal to the ratio of A minus over HA. So that's our first equation. Our second equation is essentially knowing that A minus plus HA is equal to the 70 millimolar, 0.07 molar. That is the concentration of the buffer. Okay, so I'm going to substitute in, I'm going to express HA in terms of A minus by multiplying both sides by the HA concentration here. So I get 7.079 times HA is equal to the concentration of A minus, and I'm going to use this value for A minus to substitute into this equation, and I am going to add the two together and have 8.079 times HA equal to 0.07. That's this HA plus 7.079 times HA. What that gives me when I solve it out is an HA concentration of 0.0087 molar and an A minus concentration by difference of 0.06, that's a 0, 613 molar. Okay, those are our concentrations, but how much do we actually weigh out in the solution? Now for the conjugate base, A minus, we are going to say 0.0613, that's in moles per liter, times our volume of 0.7 liters. Okay, gives us a number of moles, which is 0.0429 moles. Now, how many grams would that be? We'll multiply by the molecular weight of 70 grams per mole, and that gives us a value of 3.01 grams. Now, for the acid, we have to figure out how many moles, so it's 0.0087 moles per liter times the volume of buffer that we're making. This gives us a number of moles, which is 0.00609 moles. Now I have a stock solution that's 0.7 moles per liter, so I need to divide that by the concentration of my stock solution to get my unit in liters. Okay, so that gives me looks like 0.0087 liters, which is 8.7 milliliters. Okay, so that was the first part of the question, how to make the buffer. The second part of this question was just a short figure out the pKa given the pH and the composition of the buffer. So you knew that you added 1.81 grams at 121.1 grams per mole. I'm using my units to cancel out here to give me the right values, which is 0.0149 moles of A minus. We are in 0.75 liters, so I can get my concentration then at 0.0199 molar. For the HA, it says that I use 37.51 mils, or that many liters, times 2 moles per liter, which is 0.07502 moles. It's going to be in 0.75 liters final, so my concentration is 0.1 molar. Now I just use the Henderson-Hasselbalch, say the pH, as the pH in the question is given at 7.4, is equal to this pKa, which is our unknown, plus the log of A minus over HA. If I substitute in my values here, I can solve for the pKa minus this value here, and I come up with a pKa of 8.1 for that mystery weak acid.